So we're supposed to use substitution somehow to evaluate this integral. It looks kind of complicated. Make a guess, check out what du is, and if it doesn't work, just go back to the drawing board. Let's guess natural log to the fifth power of x. That's what that crappy notation says. Okay, I hate that we do it that way. It should be like this, because students are confused enough when they're doing calculus. We don't need to do something even weirder. That's the same thing as what you see up there. So if that's my u, then du is going to be 5 natural log x to the fourth power, right? The power comes down and then gets reduced by 1. But then I need to multiply it by a derivative of the innermost function. The derivative of natural log of x is 1 over x. Okay? So you might think, well, yeah, we kind of have a natural log x to the fourth. This is x to the fifth, so we can just take 4 out of them. But remember, this is going to be your u, so you've already substituted this. So now we have this weird thing that's mixed with u and x, and we don't have a full du after making that u substitution. So my guess was wrong. We got to go back to the drawing board. Okay. So let's try something simpler. Let's try not natural log to the fifth power. Let's just see if maybe u is supposed to be natural log of x. Because the derivative of natural log of x is 1 over x. That's what we've got down here. This is 1 over x, right? So we've got our du. And if we let that be our u, remember this is notation for the fifth power. So that's u to the fifth. And then this divide by x, you could say that's the same thing as multiplying by 1 over x. That's going to be our du. 1 over x is du. So we made our substitution there. And now we're ready to take an antiderivative because now it's much simpler. So our antiderivative is 1/6 u to the 6 plus some constant c. Because the power goes up by 1, yeah, you probably know the drill at this point. And then we can plug back in our substitution for u. And there we go.